Hey everyone, my name is Daniel Katz. I'm a senior software engineer over at Bloomberg and one of the lead organizers of the NYC++ Meetup. This is the somehow fourth event that we're holding, and for those of you who made one of our last events over at Adobe or NYU, welcome back. For those of you who are joining us for the first time, thank you so much for coming, and I hope you're enjoying the evening and the pizza so far. I'd like to start by thanking MongoDB for welcoming us into their offices, and it's of course because of organizations like MongoDB that we are able to hold these meetups in the first place. I think for me, tonight also feels a little like extra cool to be hosting here because, as I'm sure many of you know, and as I mentioned in other meetups, for many years MongoDB held an awesome series of meetups for New York City for C++, and when I was just fresh out of college, I attended some of those in 2013. I'm sure many of you attended them as well. A lot of great speakers and presentations. So it just feels, sort of extra cool for me to now be like partnering with them, or for us to be partnering with them. So Rama, Vishnu, and Gregory from MongoDB, thank you so much for helping us to put this event together tonight. And I'd just love to have a big round, first for them, And once more, I'd like to have a big round of applause for MongoDB, not just for hosting tonight, but for years of support and investment in New York C++ community. Awesome, thank you. So I always like to emphasize NYC++ Meetup. It's a place for users of C++ in New York. That's a broad audience, right? That is university students, that's boot camp graduates. You're using the language for the first time, or if you already have very strongly held opinions about type versus value-based reflection, right? It's all of those. But this meetup is a venue for users of the language in this region to come together to exchange ideas and network. Yes, of course, to eat some great food and to hear some great talks by thought leaders at the vanguard of this discipline. And so speaking of thought leaders, I'm going to invite one up to introduce another. I'd like to welcome back to NYC++ David Senkel to introduce tonight's featured speaker.
Hello. So I have a question for you. Raise your hand if you know somebody who's written a C++ compiler from scratch. Okay, I see some hands. All right. Now, how many people know Sean Baxter? Raise your hands. See, same people. Like, who writes a C++ compiler from scratch? That's absolutely ridiculous. It's insane. I mean, it really is insane. But aside from being insane, Sean is actually brilliant, okay? And he has an idea like every single week. Like I happen to be on his text feed. He'll tell me like when he has like a great idea. It's awesome. But he's had 2 ideas that are absolutely mind-blowingly unique, brilliant, that nobody in the world was ever going to come up with. And the first one was circle-style metaprogramming. And the second one, this is the first public discussion and showing of the second brilliant idea from Sean Baxter. So I'm his official hype guy, by the way. But that's all I'm going to say. So like, get ready. Like, this is going to be super sweet. So here's Sean.
Thank you, David. All right. Circle evolve C++, one simple trick to unshackle creativity in C++ language evolution. I'm going to implant some ideas with alternative titles. How to turn C++ into a language research platform. This talk will tell you how to do that. How to incentivize investment in language technology. It's kind of a hard sell to put people on tools, but this might make it an incrementally easier sell. Controversially, a no consensus model for C++ governance. Is consensus good? Can we live without consensus? Finally, a case for optimism in C++. I think in the last few years, optimism is really hard to come by, and a lot of people are on the defensive, and they act defensively. But I think there's decades of productive life left in this language. Last year, we had the Year of the Successor Languages. There was the Carbon announcement, the CPP2 announcement, and the VAL announcement. What is the motivation for starting a new language as opposed to extending C++? Let's consider the motivation behind the carbon effort. Number one, as Chandler showed in this CPP North talk, C++ has accumulated decades of technical debt. People talk about the wrong defaults of the language, and this is what they mean. This technical debt costs billions of dollars to businesses. Number two, the guiding star of C++'s history is backwards compatibility. The whole point is not to break existing code, and therefore, new features all look like workarounds. Look at these silly new keywords. You can't just use await or yield because those would clash with identifiers that are out in the wild. So they're trying to do some deconfliction by mangling new features. The consequence is that C++'s commitment to backwards compatibility prevents fixing its technical debt. We're trapped. We can't fix the technical debt because we can't break or change the meaning of existing code. And this idea has launched 3 successor language efforts last year alone. Carbon, this is from their documents, cites the accumulation of technical debt, by which they mean language decision choices they don't like, as the motivation for starting a whole new tool chain. They call out specific examples like integer promotion rules and complex declaration syntax. They say over time, this has resulted in significant technical debt ranging from integer promotion to complex syntax with the quote, most vexing parse. Here is a list of 10 wrong defaults that I compiled. Integral promotions are surprising. Implicit knowing conversions, you lose data, and that does produce bugs. Switches should probably break rather than fall through. Operator precedence is really complicated, and for bitwise ops, it's wrong. Declarations are too hard to parse, and you get the most vexing parse. The template brackets with the angles, that's a true nightmare to parse. That has really slowed down tooling. It requires users to disambiguate things manually. Stood forward is error prone. Graced initializer can choose the wrong constructor, especially with like giving it initializer lists for vectors. 0, why is that? No pointer constant, so we put the no pointer keyword, but 0 still works. And this shouldn't be a pointer, it should be like an L value. And a system that can't fix its mistakes is an unhealthy system. So no question, no wonder why there's 3 challengers to C++. We have to ask ourselves, does the commitment to backwards compatibility actually prevent fixing technical debt? No, it doesn't. We can fix C++. Those 10 defects have 10 fixes. All these fixes are independently versioned. You can choose which ones you want. You can take the whole suite of them. They're easy to implement. If you identify a defect, you can fix it. We can fix our mistakes. Fixing defects is crucial, but I want to evolve C++ to meet tomorrow's programming challenges. What is this? All right, you see first class choice type, a discriminated union on line 7. Think Rust's enum. You see FN and var declarations on 13 and 14. That's not C++. You have a new syntax for initializing choice objects on line 17 and line 24. Dot failure, dot success, like the int result name's not named there, just finds it through deduction. And you have pattern matching on the right-hand side, line 29. There's a match statement, and it uses, it decomposes the choice to find the active alternative. Like what is this thing? Is this still C++? And so yes, this is C++ pushed into new territory. This is a almost one-to-one copy of a Rust traits example from Rust by Examples. Interfaces on line 7, that's a Rust trait, and they define a collection of methods. And impl implements that method for a type. So on line 34 on the right, we're saying that sheep implements iAnimal, and I provide definitions for all the interface methods from iAnimal. This is an organizational alternative to function overloading and class member functions. This is very Rust-like code, but it's C++. I am including string view and IOStream, and ordinary C++ constructs work, except for when they've been replaced with my modernization. So on line 20 and 21, I have non-static data members, naked and name, and those use this new disambiguated form of declaration. This is C++, as far as I'm concerned. It fits into a C++ tool chain, and it doesn't break any of your dependencies. Bubbles of new code. When Herb Sutter announced CPP2, he had this metaphor that if we had a new language syntax, that would give us, quote, bubbles of new code by which we can fix defects and make arbitrary improvements. And he lists a bunch of the defects I've already listed too, like make the language context-free and order independent, and turn off unsafe parts like implicit conversions, free of backward source compatibility constraints. I like the metaphor, I like the idea of bubbles of new code. I want bubbles of new code. I don't want a new language. My bold idea is simply declare that your code operates by new rules and not the old rules. There is no new syntax that replaces the old syntax. We're simply stating that we want the compiler to operate by new rules that we can choose. A feature changes the language within a region of text, and that feature is contained within this bubble of new code. And it's very important for my development velocity, and I think for everyone understanding the impact of each of these features, to keep them small and independent. So you can choose which of these to activate. I can activate the as feature, the choice feature, forward, and they don't have any dependencies among each other. And they all have, hopefully, a fairly well-defined, small impact on the overall language. Okay, so my mechanism for enabling bubbles of new code is the feature directive. Each textual file you load, a CPP file or a header file, has an active mask of features. Initially, that mask is cleared for every file. These are not like command line options. You put the feature directive directly in each individual file, and only that one file is affected. So you can turn on feature, say #feature on, and then the feature name's in green. #feature off will turn them off inside a file, or you can reset, which is good for emitting out the preprocessed code. Or you can say #feature include path, and that'll open a file, which is a manifest, and it lists all the features for that individual file. The token, the active mask is recorded to the token stream at each source location. So on line 1, I'm turning on 3 features, and on line 5, I'm emitting 5 tokens. Now those tokens are emitted with these 3 features. So when the compiler has to deal with that int x = 1, it knows that the ADL, the choice, and the tuple features are active. So it can take special behaviors and modify translation if it has to. In this case, there's nothing to modify. On line 7, I activate a 4th feature, and now on line 11, those 5 tokens are emitted along with their feature masks. So this produces a token stream, as all translation units are just token streams, but with each token, there's a mask of the active features that were defined when that token was emitted. Now, the compiler Circle can take feature-specific actions based on the mask at each source location. So it can recognize different keywords. The line 7, feature on interface, has the effect of making interface a keyword now. So after line 7, interface would be a keyword to be picked up. It can enable different syntax and can enable different semantics. Crucially, this does not affect existing code. It does not affect your headers, or if you're writing in a header, it doesn't affect your users. Okay, so here's an example of features adding keywords. Line 4 and 5, I have declarations of objects called interface and impl, and then I turn on the interface feature and the self feature. Now on line 11, interface is no longer an identifier. It does not refer to that object. It refers to a new language entity, the interface, like a Rust trait. So I'm declaring the iPrint interface, and I'm declaring and defining the print method. On line 13, you see self. Self is no longer a normal identifier. That's a keyword now. That's like the improve this. So I've just changed the surface of the language by telling it I want this interface capability. Line 19, I'm using impl, that's a new construct, int, double, iPrint. That means I'm bringing into the scope 2 implementations of iPrint, ints and doubles. And now on line 26 and 27, I can call member functions x.print and y.print on built-ins. X is not a class. X does not have member functions. Y is a double. It does not have member functions. But I'm using the syntax x.print because of the external extension, this extra method that's been added to the type through the impl. And it can find that because I brought it into scope on line 19. I've just shadowed a bunch of 5 different keywords because the interface and self features have added new keywords. So how do I've shadowed those objects I have on line 4, but I can still access them with backticks. So this is something I put in which is really useful, I think. Any string in backticks is now an identifier. That can be a keyword like double, where you can no longer, before you can even have like a object called static cast, even though static cast, I mean, that could appear in C code, right? Because that's not a reserved word in C. So how would you access from C++? Here you can just backtick it. And this is important when you can introduce new keywords as part of a feature. So I can access those old object definitions by backticking them, or I can just turn the feature off and get back at them. All right, here's an example of features changing behavior. The Carbon folks have this flowchart on how operators behave and what their precedences are. And it's called partial precedence because not all operators have defined precedences. And this also changes the relative precedence of the binary operators with the relational operators. So on the code on the left, line 6 is ordinary ISO C++. And the mask is 7 and the value is 3. Now, 7 bitwise and 3 should be 3. But that comparison is not equal to 3 because the operator precedence is so screwy. Like the 3 not equal mask binds tighter than the mask and value. And everyone in the modern world thinks of this as an arithmetic operation. Nobody thinks of it as a logical operation, except for in like 1971 when they did this. And we've carried that 50 years of technical debt. That's literally 5 decades of technical debt. But we can fix it with a one-liner, right? So I said feature on simpler precedence, and now the whole binary expression parsing has been replaced with this flowchart on the right. And so now 3 is equal to mask and value. I've changed the precedence of this operation. So that's the kind of capabilities you get with these features. I gotta like hammer this home, that the feature mask has no effect on files that are outside of the file that activates it. If inside a CPP file, if you activate a feature, that has no effect on the files you're including. Likewise, if you're writing a header file for a library, the feature mask has no effect on your users. Like the files are all independently featured, and I'm sure I'm going to get like questions later on of people not absorbing this because it's so weird. And this is like the genius idea that David was saying, that like the genius idea here is that files are all different things. And that's like hard for us to understand because we've been dealing with translation units, which is the concatenation of text for these 50 years. But like it's really nice to think about files as being self-contained entities. And finally, you don't have to use these directives. I don't want you to mark up your code with pound feature on XYZ, W, etc. Make a feature file like project.fts somewhere in your project and list the features you want to use. And then just include it from every source file. All right, how to deploy features at scale. So if you have an existing project and you want to turn on some safety features, maybe ones that nag you if you use ADL or call an ADL function, or you do a narrowing conversion. Great, create a features file, and then every file in the folders you're upgrading can include that. Add a feature to the file, and then run your build. And if something breaks, you know why it broke, because you're adding these things one at a time. So if you have a no floating point narrowing feature and you turn that on, and something breaks, you know it's related to floating point narrowing, and the error will be pretty explicit. And so you can resolve your problems, and then as you have more features, just keep adding them to the file, and then at the end, well, you've just upgraded your source file without rewriting anything. This is just reactive. It's a lot. I think it's a much better story than saying rewrite it in CPP2, rewrite it in Carbon. Like that's just introducing new bugs, and it's just really hard since those don't exist. Features extend the productive lifetime of C++. I think we should get rid of bad things. We should add good things, and we can do it without breaking or changing the meaning of existing code. And I think the real thing here is we need to learn how to innovate without achieving consensus. Features are opt-in. No one is forcing their preferences on you. When you go to a restaurant, does a fight break out if the whole table doesn't order the same dish? No, like let people do what they want. And by people, I mean institutional users. The companies that really support C++ tools, they have, they employ lots of people. And if they believe something is valuable to their organization, they should have a path to make that work, regardless of the WG21 consensus. All right, so I'm gonna do 2 quick examples, and here we go. No integral promotions. Consider C++ arithmetic without the no integral promotions feature. You multiply 2 characters and you get an int. You multiply 2 unshorts and you get an int. Like that's surprising. I don't know why that is. I think the best anyone could say is it's historical. Surprising is generally bad, right? So people want to turn off integral promotions. So we can do that on line 8. We say no integral promotions. And now when you multiply 2 characters, you get a character back. When you multiply 2 W-char-T, you get one of those guys back too. Like we were able to change the language in a fundamental way, erasing 50 years of technical debt, and we didn't even have to create an all-new programming language. New decal syntax. If a declaration can be parsed as a function, it is parsed as a function. That's often not what you expect. So line 12 is an example of the most vexing parse. I think all of us have run into this many times in our lives, and you stare at it for like a minute and you realize, it's the most vexing parse, it's really dumb, and then you disambiguate, you put an equal in there, or you put braces or something. Line 20, that is a context-sensitive parse inherited from C, A star B. You don't know without doing a lot of analysis if that's a pointer declaration or if that is a multiplication. And on the C++ side, that requires us to use the : the type name, and then for nested name inside templates. It's like, it's very hard to explain to people why that's the case. So that's bad. So what if we were just to create an all new declaration syntax? So now fn in front of a function declares a function. Var in front of a object declares an object or a data member. This removes the simple declaration part of the grammar, which is C++'s biggest syntactic mess. Unless you've really studied the ISO standard gram section at the end, you probably don't know like how much stuff is rolled into simple declaration. Type defs, all declarations are rolled into this, including class definitions. Like these are all rolled into this one horrific bit of grammar, and it's not surprising that it has vexing issues. And so I want to get rid of like the vexing aspects without breaking projects. So to go back to the Carbon manifesto, they cite the integer promotion rules and the most vexing parse as motivators for starting a new language from scratch. I fixed those without creating an all-new language, right? They said it couldn't be done. Like, of course we can make little fixes. Of course we can modernize this thing. We can drag it like into the next decade without it exploding on us. All right. I talk a lot about individual features, but I bundle them into additions. And I think this is the way users should use them. This keeps people on the same page about what to expect from the language. So edition 2023 is the kind of like the Sean mix, right? It has on the left some richness features. These improve the language with new features. And on the right, there's safety ones. If you don't care about like implicit conversions or whatever, you can opt out of any of these. These are all optional. So you can disaggregate my edition. You don't have to use my edition, but this keeps people on the same page. And we can explore other language ideas by bundling relevant features into editions. So I have a Carbon-like experience, which inherits all the features from edition 2023 and adds 6 more simplicity features. So Carbon is basically somewhat modernized C++ with a lot of stuff disabled. It doesn't have function overloading. You're not allowed to overload functions in Carbon. So I have a no function overloading feature. If you try to overload 2 functions f and one takes an int and one takes a double, the compiler will bark at you. No multiple inheritance. Why? Because you can use interfaces and impulse. That's the idea. No user-defined constructors. Use a factory function. No virtual inheritance. I understand that one. That's a horrible thing. The C++ wit Victor said that I implemented every programming language as a set of pragmas. And yeah, I mean, you should be able to do that. Okay, so this is a condition, it's like a serious condition, isobrain, where you see something that you like and it's, oh, this is necessary, but features other people like, and you will say the language is already too complex. Do you see the contradiction? Take a moment to think about what I'm presenting before deciding you hate it. Do I personally like everything I'm showing? No. A lot of stuff I built I don't care about, but the idea is to have velocity and to work through the whole configuration space of language aspects. C++ has a diversity of users with a diversity of requirements, and that's a good thing. And I think that this attitude is bad. Thinking C++ is doomed is easy. Thinking that it's ripe with potential, that takes independence of thought. So come with me, independent thinkers. It's time to put creativity at the center of C++ discourse. This is me. I am Titan Prometheus, bringing to mortals the flame of creativity. I've taken some giant swings with the extensions I've written. I want other people to have the same license to be creative that I have. Right now, people they feel they can't innovate because of the prohibition on breaking or changing the meaning of existing code. But that is a problem only in the mind. People have ideas, and I want them to shepherd those ideas into physical existence. Sadly, this is also me. An eagle eating your liver is an ancient Greek metaphor for writing your own compiler. Software is really cheap to construct. I think we should try everything. I launched this new circle, feature-aware circle, with 30 features. I have reached a Zen state of non-attachment to individual features. What matters to me is rapid iteration to find a good balance of power and clarity. Individually, it's even hard to say if a feature is good or not, but they might gel with other adjacent features. So I think it's important to just try everything, and the things that don't really like punch above their weight, and then get tossed, or someone else might find a use for them. Starting with a working compiler builds confidence in your ideas. I've decided to embrace that technical debt and work from an existing tool chain. I have a compiler, whereas the successor languages do not. You know, everything I'm showing you here exists, it's real, and I've got compiler explorer links. It builds on top of standard C++. If you think that you have to start a new language because C++ is infixable, that's a faulty assumption that costs lots of time and effort and gets you nowhere. It's expensive to move people over to a new programming language, and you need to have a good reason for asking for that. I just can't imagine trying to start from scratch with something that's going to have a high level of C++ interoperability. The implication is that you're going to end up writing a new C++ compiler. All right, two other features. So, implicit conversions. This is a Jason Turner video where he says implicit conversions are evil. Okay, so he wants them to be disabled, and I say, okay, well we should please him and we should please everybody. So I have all these 6 no implicit blah blah blah, no implicit floating point narrowing, integer narrowing, enum to underlying, which is the integer type. No implicit pointer to bool. That's a really bad one. You don't want to convert pointers to bools, but that's like high precedence. No implicit constructors called in implicit conversion sequences, and no implicit user-defined conversions in ICSs. And also as is really nice. I got this from Rust. I stole a lot of stuff from Rust. Expr as is a keyword, type ID. It's just a nicer static cast, which is, that's fine. Expr as underscore, that enables an implicit conversion that was previously disabled. So, this is great. This is great. All right. So at the top, line 1, I'm turning on no implicit integral narrowing, no implicit floating point narrowing, and as. So I have some functions, fshort, fint, and float, and they take the respective parameter types. Line 9, I'm calling fshort, and I'm passing it an int. Now, that's a narrowing conversion, right? I can't pass an int to a short unless it's const expr, and I can verify that there's not narrowing. So the compiler tells me which feature was violated. In brackets, no implicit floating narrowing. That's the feature I turned on, and that's the violation. No implicit conversion from no implicit conversion from int to short, the top one, yeah. So it tells me that it got an int and it was trying to convert it to a short. And now I have two options. I can say x as short, which is an explicit conversion, that's like a static cast, or x as underscore, and that permits that conversion, that implicit conversion. So this is like a form of static analysis. You run it on your code and it gives you a prompt. It's like a yes, no, or what do you want to do here? You can either convert it explicitly or you can just say as underscore and just let it go through. Same thing with double to floats. And the last one errors because it's no implicit conversion from double to int. That's a floating point narrowing. ADL, argument dependent lookup. Jason Turner says implicit conversions are evil. Sean Parent says argument dependent lookup is evil. Everyone has some particular thing that they really want to change. Why not provide what they want? In the source at the right, I turn on the ADL feature. That makes ADL a keyword. Calling the function candidate found by argument dependent lookup now requires using the ADL keyword. If you don't use the keyword, the compiler will nag and tell you which candidate it tried to call. Now you have the option to explicitly qualify the namespace as x1 does. Say x1 says stood : so that's no ADLs used there. Or you can use the ADL keyword to permit this invocation of an ADL found candidate. You can see the error message at the bottom. It's pretty wordy, but it says ADL candidate called without ADL token before unqualified name. It tells you which candidate was found and it tells you where in the source. So you can go hunt it down and say, this is the one I intended to call, or it's not. Forward. Why does T ampersand mean forwarding parameter in C++11? Like, how do you actually even declare a R value reference? You can't. It's weird. This feature makes forward a keyword, and that keyword can be used as a parameter directive on a parameter, and it can be used as an expression. So I can use it in front of arguments and in front of parameters. And it can't be used incorrectly. Forward expression must name a forwarding parameter. If it does not name, if it names some other kind of object or a parameter that's not declared with the forward directive, that program is ill-formed. You can't inadvertently use stood forward, since forward is now a keyword. So if you write stood : forward, it says, well, there's a keyword after stood : So you actually have to go out of your way and backtick forward. So it kind of locks you out of doing the wrong thing. Here's an example of why it's so good. I got this from the CPP front code. CPP2 forward is a macro. It takes the decal type of X, and then it sends that to X. And this is a trap. Like, you have to be real careful. Line 15, I'm taking an R value reference, not R value reference, it's a forwarding reference, auto amp, and I'm passing object.first and object.second. I'm trying to break apart this pair and forward the pairwise elements. But number one is not right, but it's not ill-formed, it just does the wrong thing. If you say object.first and forward that, it forwards it as an R value all the time, 100% of the time. It doesn't matter if it came in as an L value. Well, that's dumb, right? Because we just wrote this macro to make it easy, but it's unsafe. Number two is the right way to do it. So you have to forward the parameter and then dot first or dot second, but everybody falls into this trap. So why do we even have this? Right, the good forward is on line 1, feature on forward. So now forward is a keyword, and we can use it as a parameter directive, so there's no more references there, right? And we can use it on line 11 and line 15 as part of an argument. So I can say forward pair dot first and forward pair dot second. It just does the right thing. Forward has high precedence, so it first matches the parameter, and it will turn that into an L value or an R value expression, or an X value expression, and then it'll get the member, and the member will inherit the value category from the left-hand side. And on the program output, we see that now, we've decomposed our L value pair into an int L value and a double L value. So this works, and it can't break because forward is only declared to work on forwarding parameters. Simple precedence. Okay, operator precedence in C++ is bad. It's easy to make mistakes, and bitwise ops are in the wrong place. So before the carbon people have this graph, which is, I think it's like a really nice feature. I think it's the best simplification they have in there. Okay, this is an example of how it nags you. Line 6, I'm mixing two kinds of logical operators. Now I know which one is higher precedence, but not everybody does. So line 6 is an error. It says cannot follow operator or with operator and. Then you have to go through and disambiguate it with parentheses yourself. Same with line 9. Hardly anybody uses bitwise XOR. So if does that have higher or lower precedence than bitwise OR? Like, right? It's like then you got to go to that stupid chart and look it up. But like here, well, you can't misuse it. I think this is a great bit of static analysis that has really no downsides. Choice. So this is the type-safe discriminated union. It's like Rust's enum. And that brings in, when you have a choice type, you have to decompose it. And for C++, we have std variant, but std variant has like a visitor pattern, which is awful. So we want pattern matching because modern languages have that. So the pattern match is the way to decompose a choice type or like a Rust enum. This is my third attempt at C++ pattern matching. At CPPCon 2021, Herb gave like a 90-minute talk on pattern matching. I'll do the same, but in like 90 seconds. For what it's worth, I think this is a better defined pattern matching feature. It's a lot simpler to understand. And I should know because I also wrote that one that Herb shows. So, you know, this is nice. And the choice types are great because like it allows us to use idioms from other languages. So almost every object in Rust comes in wrapped in like an option or a result enum, depending on if it's defined or if it may return an error. And this feature allows us to replicate that pretty much exactly. All right, choice types. Each alternative has a name. So I'm creating a shape, circle, square, and point. Those are the alternative names. Payload types are optional. And it's got no value list by exception state. If you ever dealt with std variant, it's possible if one of your variant alternatives has a potentially throwing copy constructor, then your variant can end up in a zombie state, which requires special handling. And that was a real like bug it's a defect in the specification, I think. So this doesn't do that. Type-based variant falls out with member pack declaration. If you saw my like CPP Now talk last year, I have a whole bunch on member packs. Line 22 is using a pack expansion inside of a choice definition. So I can spam out the parameter pack TS and create various variant alternatives. So this is like functionally a variant in, like one line. And for initializers, the .name with curly braces or parentheses creates instances without qualifying the choice type. That's, it can infer that from context. And that's a Rustism. Match. On the left-hand side of a match, we have the pattern, and the pattern is recursively defined. This is my third attempt at doing this, but I kind of thought that C# has a good approach, so I pretty much copied what they do. There's three kinds of destructurizations. The first one is a structured binding. That just says if you have a tuple thing or a tuple-like thing or an aggregate, you can destructure it into its elements, and that's with square brackets, just like a structured binding. There's the designated binding here, which is kind of like curly brace with like X equal, the designated initializer in C++20. So it kind of takes the same thing there. So instead of like matching things by position, it matches them by name. And this only works for class types. And finally, .name, and then parentheses, that matches the active choice alternative. So this is special for choices, right? I mean, bindings, you can also like bind a variable name to whatever your input is. So you can use AutoX unless you have that new decal syntax, then you can use var, because var is a keyword in that new syntax. You can do the same thing with packs. Wildcards. Underscore is a wildcard, matches one thing, ... matches a pack of things, but you only get one of those per pattern, and it'll expand or contract itself accordingly. And then tests. So you can put any expression in there, it'll match that. You can put you can name a bool valued function or an overload set, and it'll call that. A ... B creates a range test. So if is your argument X greater than or equal to A and less than B, and then you've got these kind of one-sided comparisons below that. That's done in C#, so there's precedence for these things. And finally, we have logical tests. So you can, if you want to be clever, that's cool. You can say var X, var Y, var Z. I've just bound three things, then use an if guard at the end to compare them. That's one way to write it. Or you can say var X, so I've bound X, and then X and X, and those are both expressions in that context. So it's binding X and then matching the next two expressions. So those are equivalent. It's just you can use whatever ninja skills you want here. This is an example of a match statement. Since I'm feeding it a choice type, I'm starting with a destructure, a choice alternative map. So .my tuple, if the active alternative is a my tuple, then you go inside the pattern, and now I destructure 1, var b's because the payload is a tuple. So if that integer is valued 1, then it matches, and it also binds b to the value of the string. Very basic stuff here, and it's sort of something we'd expect from other languages. This is another example without using choices here, showing you can feed it functions like even, you can feed it ranges like 10 to 20, or you can queue up 1 or 3 or 7 or 9. If any of those match, you go through. It's basic stuff that you get from managed languages like C#. Interface. Okay, this is like really complicated. This was like half, maybe 60 or 70% of all the effort required for this new version of Circle. So I have 30 features, and this is like 70% of the effort. So certain modern programming disciples think that they have two goals for organizing functions. First is to decouple the function from the data. This is anti-object-oriented programming. Object-oriented programming is encapsulation. This is like decapsulation. And they really like that. And then by doing, and they also want to avoid overload resolution complexity. So if you have these two goals in mind, which you don't have these goals as a C++ person because C++ is predicated on a different set of ideals, but something like Swift or Rust is predicated on these, this may not make sense, but it will a little bit. So there's three ways to organize functions. Number one is object-oriented. So you see on lines 2 and 3, we have types A1 and AB, and they have member functions. And so when you'd call it, you just say like A1.print, and that works great. The problem here is that those are internal declarations. You can't externally extend A1's definition. There's no distance between declaring its data and declaring its functions. Number two is free functions. Let's say I have types A2 and B2, and I want to externally provide functionality for those types. In C++, you'd use overload resolution. So I have one function overload set called print, and there's two specific overloads, one that takes an A2 and one that takes a B2. That's great that it's externally defined, but now we have overload resolution. In this case, it's trivial. Overload resolution is like incredibly complicated. So the Rust people have traits, and the Carbon people will say, we want to call those interfaces, because traits already mean something in C++. So I said, let's call it interfaces. This ticks both of those boxes. So an interface permits external declarations of functionality, like lines 19 and 20 are data. Those are defined in one place, and then the impl, or the interface, is defined externally to that. And also, there's no functional overloading required here, because when you have an object, it's a straight shot to getting its impl. It's really a specialization of this magical template called impl, where you provide both a type and an interface, and it locates your functions. There's no overload resolution required. So if we enable the interface keyword, we draw the interface feature, we draw 4 keywords in. Interface, impl, it's just like Rust impls. Dyn, this is first-class dynamic type erasure. This is a type that is specialized over an interface. And make dyn, this is the expression that does the type erasure and returns to you a dyn type. All right, so here's an example of using interfaces. So I'm going to declare an interface I print. After it, I'm going to say auto, and this means that it can be implicitly implemented by a type that already has a print method or that has a valid default right there. This goes back to the C++ like OX debate with Doug Greger from 2006 about where to put the auto. There was a lot of like back and forth, so I kind of went with the consensus on that before that feature was removed from the standard. So this debate goes back to maybe like 2004, 2005. So there was really a lot of working group work on this feature, but it just got removed. So I tried to kind of resume it where they left off. All right, so any types that are arithmetic, this print method already has a definition, so I don't have to define my own impl. So now lines 16 and 17, I'm declaring an int and a double, and then I'm calling this function on them, and this will call via the impl. You can call methods on built-in types like no big deal. That's gets a lot of people really excited because you're no longer limited by somebody's object-oriented design. You can take their object, and then you can add new functionality on top of it. That really looks like it was baked into the type from the beginning. All right, type parameters are constrained by interfaces. So line 11, I want to declare a template, but I want to constrain the argument or the parameter type based on some interface. So you say type name2, that's just any type, but now that has to implement iprint. And you can chain them together. You say iprint and isave and iserialize or something, right? All of those, that becomes a constraint, and also it brings those impls into the namespace. So now I can call object.print on the integers passed in line 17 and the double pass in line 18, and it prints them for me. So there's a lot of implicit plumbing in here to create this Rust-like feature set. Here are 2 explicit specializations of impls. So impl double implements iprint, and on line 9, that's again just like Swift or Rust. Line 15 is a generic version, so I can have a templated impl, and here it takes any type T that is constrained to be arithmetic, so like int, short, character, whatever, and uses templates to provide implementation of the print member function. So if you can use the default, you can use the defaults here on line 6. You see the default implementation, but if you don't have a default that works for all the types, you can provide your own. Now, I think this is where people will get excited. I don't know. Even if you think you don't want interfaces, you may really want interfaces, because type erasure or external polymorphism. At all these conferences, there are like external polymorphism, aka type erasure talks. The one on the top right, the Klaus Igelberger one, is like a very sober analysis, and he goes through all the plumbing required to get type erasure. Eric Niebler said, instead of going, like, if he could go back in time, instead of killing Hitler, he would like put in type erasure instead of virtual functions. Like, that's incredible. Like, who thinks like virtual functions are the core of C++? But a lot of thought leaders out there would rather have type erasures than virtual functions, right? You know, everyone wants type erasure. Why won't anyone do something? All right, so here's the type erasure feature. Type erasure is external polymorphism. Dyn is a template. You specialize it over an interface, and that is a type that erases another type. Now, you can access that underlying object through the interface that's specified in there. Dyn star is a fat pointer. This is just like Rust. It's 16 bytes instead of 8 bytes. So there's a pointer that points to data, and there's a pointer that points to a dyne table. It's a virtual table, but the virtual table is now decoupled from your data. So normally, when you're writing object-oriented code, you write virtual functions, and if there's one or more virtual functions, then the first slot in the data is a pointer to the virtual table. And so any member function that's virtual that you call on that object will do an indirection, it'll like load out the virtual pointer, and then it'll chase that down and get the virtual function pointer. But we can't do that because we've already defined the layout of the type, right? We already have a struct, and then after the struct has been fully defined, we're externally adding new functionality to it. So if we want to have virtual functions, we can't use a virtual pointer because that struct is already baked. So we have to pass around that virtual pointer with the actual dyne star, and that's the fat pointer. Make dyne is the operator that converts a normal pointer to a fat pointer. And you can also upcast. So you can, if you have a dyne, like the derived interface, you can upcast it to the base interface. So I try to keep it like C++, where you can cast from derived, or you can implicitly convert from a derived pointer to a base pointer, and here you can do that from a derived interface to a base interface. All right, here's an example. So only lines 27 and down are really new. So on 22 and 23, I have two objects. I have an int and a string, and I want to store both of those in a vector, but they're unrelated types. So in C++, you could use like std_any, but std_any is really bad. It has no interface. It's quite useless. But here we can use type erasure. So we can convert the int star and x into a dyne iface, and we can do that because int implements the iface interface. And so now that operator gives us back a fat pointer where the first pointer points to x, and the second pointer points to the virtual table, showing how int implements that print member function for iface. And we can do the same thing with string. So now I've got a vector, a container loaded with completely heterogeneous objects. And we can invoke them. So on 33 and 34, I'm getting the first element, I'm calling print, and I'm getting the second element, I'm calling print. That's like, this is it. There's no additional plumbing you have to use type erasure in its most basic form. Value semantics. When type erasure comes up, people say, well, is it type erasure with value semantics? And they mean, does it have a copy constructor and a copy assignment operator? How do we achieve value semantics with type erased objects? We don't know what the type of the object is. How do we call the copy constructor? We know that the object implements iPrint, but we don't know if it's a stood string. If it's a stood string, we could just copy it, but we don't know what it is. The type is hidden, so we have to implement a clone method. Now, this is like built into the Rust framework. It has a clone interface with a clone interface method. I want to do the same thing, but without this kind of special case. I want to make it more programmable. And we have some additional tooling that Rust doesn't have in the form of 9 kinds of template parameters. So I gave a talk last year, and back then I had 6 kinds of template parameters. This is an incredible increase. This is amazing productivity in template parameter kinds. So ISO C++ has a poverty of template parameter kinds. It has non-types, types, and type templates. I've added variable templates, concepts, interfaces, interface templates, namespaces. You can pass namespaces as template parameters, and then you can use like dependent namespaces, and the universal template parameter, which is really nice. This just shows that they work, and you can, on the right-hand side, I'm passing all these entities and using reflection. You can see I have line 17 through 25, I have like a string literal, and then I can call .format, but that's all compile time, like they built into the compiler. And that squiggly non-type, squiggly string, non-type, or type tilde string, et cetera, that is reflection. So that returns the compiler's formatting of the entity into a string. So I have support for interfaces and interface templates, and that's crucial for value semantics because it allows me to implement the iClone pattern without having the compiler know anything about it. This is all user space. Now, iClone is an interface template. It takes an interface as a parameter. It inherits from that interface. I am told by people this is a mix-in pattern. Line 18 is the clone method. It's an interface method. It returns a regular unique pointer that holds an instance of the dyne iClone. So at this point, it's type erased, right? We don't know what the result of clone is. It's this base type. It's a unique pointer managed pointer to a base interface. And if the type self is copy constructible, I'm going to allow this default implementation. So iClone has an implicit implementation for all types that are copy constructible. And that clone member function will just call make unique dyn, and it will pass an instance of itself. And that will invoke the copy constructor and return a new unique pointer. Like, you have to unpack this later, but trust me, it's really quite nice. All right, okay, now this is how we all move it together and we get the box. So in Rust, box is basically the value semantics type erase type. It's like a unique pointer, but with this assignment and copy construct operation. It's really nice to have, and as you can see, we can just wrap a unique pointer and add some additional member functions. So here's box, and box is a class template that takes an interface parameter. Interface template parameters are everywhere. Line 27 has an interface template parameter, so we're going to specialize box over iprint or isave or some concatenation of these things. So at this point, we don't know what's in the box. That's like a 7 joke. Don't open the box. Jesus. Oh my God. Fincher, come on. Okay, so the copy constructor on 39, that calls clone. But this box doesn't know what the type that's being cloned is. It has to call it through the interface. And we know that iClone, clone is implemented by that pointer. And this uses this like virtual function. So it goes to the dyn table. There's a lot of plumbing here, but this is part of the bones of Rust. And it's the thing that all of these people want, right? Everyone wants it. And there's libraries called like Dyno and Boost something that have huge amounts of macros and whatever else. This should be put in the language, right? If everyone wants it, let's put it in the language. So I think that's really good, and it'll make Rust people excited to see in a language they hate. C++ needs a path from ideas to technology. That's what I'm trying to communicate. Okay, where's David? Okay, great. I need a foil. Corporations have positions like principal scientist, architect, and staff researcher. These are professional language opiners. Language opiners conceptualize a feature like reflection or choice types or pattern matching. I think David did all three. Like, do you submit proposals for all of these? And how many made it into the text? 0. The donut. So let's do a thought experiment. So we have a professional language opiner, Dave Senkel, and he has a new idea for a feature, which is that Pig Latin variable names are immutable. They're const by default. And he talks about it with his research group, and we're like, oh, that's really good. And he does a study, and he goes to accounting, and they like go on the whiteboard, and they say, oh, this feature will save the organization $100 million over 10 years. And he's thinking like gold watch, corner office, all that. So what does he do? What are his options right now in WG21? He goes to like 6 conferences a year. He submits all these proposals. He joins a study group. He repeats this for 5 years. The company spends lots of time and money. And they're supporting this because they think that there's going to be benefit for them on the back. But there's no feature. Nothing materializes. We're leaving money on the table. Now, personally, I don't think that's a good idea, this Pig Latin thing. But professionally, what business is it of mine what he does with his company, right? I don't get trapped into ISO brain. Like, features that I like are necessary and features other people like. You can say the language is already too complex. People would use a variant of this to object to pattern matching, to choice types, to interfaces, to everything I'm showing here. But it matters to some people, and they think it impacts their business. So we need to allow users the features they want. I'm trying to provide a path from ideas to technology. Let the language opiner conceptualize the feature, and they can work with the engineers to build it, to test it in their own code, and deploy it internally for a while. They can then talk to the vendor to upstream it. So we can have a path of ideas to technology that circumvents the working group bureaucracy. I think this improves the language development value proposition. Like, everything in this talk was written by me over 6 months. The feature system encourages rapid creation. It's a lot easier to think about a feature when it's a well-defined thing. It's scoped. Like, I have a feature as, which implements the as keyword. I like to think about like this one thing. You can crank these things out, and then if you don't like it, you can toss it, you can modify it, you can do whatever you want. But the idea is that we're getting value out of supporting language development because we're rapidly able to iterate through ideas. And if we really like something and we think it's going to help us, we have a path to get it into the compiler. Companies should turn their institutional knowledge into technology, and the consensus model isn't the only way. You might be familiar with Vittorio's epochs proposal, where he had kind of a similar thing to features, but he predicated it on module boundaries instead of file scope boundaries. The big difference, though, is the emphasis on his single linear monotonically increasing sequence of language flavors. He's okay with like the, C++ 17, 20, 23, 26, etc. I kind of want more than that. I think the fine granularity of the feature scoping gets, avoids the need for consensus on something because, everything you produce is optional. Here's some research features that I am working on now. They are not available in the build because they are non-trivial. A lot of C++ people have a bad case of Rust envy. Even if they've never used Rust, they tell me how amazing it is. Don't eat your heart out. Identify the things you like in that language or other languages, and then implement them in C++. This way, C++ keeps up while supporting money-making projects. A lot of these other language enthusiasts say, well, just like rewrite everything in Rust. But there you stop making money in order to rewrite something. So it'd be great if the features that they talk about as having value could be incorporated gradually while the vehicle is moving, right? So I've already addressed some of these things, like interfaces, which are Rust traits, choice types, which are Rust enums. The new decal syntax is very similar to Rust's declaration syntax. The as feature enables Rust as expression. But now I'm working on ownership semantics in relocate and borrow checking. Those are in development. So relocation, this is a destructive move. We've talked about it for decades in C++. In C++ 11, we've got the std move and the R value reference in the X value category instead of destructive move. That's fine. People cry over that, but you shouldn't. I mean, it helped us for the last 10 years to improve the performance of containers. It was like, it's pretty good. Doesn't require much tooling. It's hard to understand, but it has trade-offs. This has other trade-offs, but I think it has a lot of strengths because it enables borrow checking. You can't borrow something if nobody owns it. So the idea of the relocation feature is to create an ownership semantic, meaning an object comes into scope with its creation. It's destroyed when it falls out of scope, or in this case, when it's relocated to a new owner. So you can relocate objects through function stacks, and that will then essentially end the life of the previous label for that object. So my implementation, relocate, is a new special member function. It's called relocate. That's a keyword. And it takes the same type. It takes a by value type. And now you can kind of peel it apart, make changes, and return a new instance. You hardly ever have to do this. Almost all types are trivially relocatable, meaning they can be relocated with a mem copy. Std unique pointer can be trivially relocatable because all you have to do is like take the old pointer and move it over. Vector, std vector is usually 3 pointers. You can just move those 3 pointers and it's trivially relocatable. Things that aren't are like std map, std list because they have self-referential references. So you have to go and adjust those. And so for those, you may be able to use the implicitly defined relocate, which does a move construct and a destruct, or you could write your own code. This is like kind of plumbing, which is maybe not that important, but it enables the body of main, which is we're going to declare a pointer P1, we're going to relocate it into P2. Now we can no longer call it on P1. The P1 label is gone, so it has been relocated. Borrow checking. We have to do relocation so we get borrow checking. I think borrow checking is like the signal feature for giving us confidence about the memory safety of C++. So Strip in December, I think, had a mailing called a call to action, thinking seriously about safety, in quotes, then do something sensible about it. It doesn't, in the text, it doesn't mention Rust, it doesn't mention borrow checking. So this is the kind of defensiveness that the C++ community is right now, where a lot of them are in denial about these alternatives. Now, I'm not expecting them to say Rust is better. I'm not expecting them to say Rust is bad. But like Rust has a strategy that's coherent for improving memory safety, both statically and at runtime. And I think it's good for me to copy what they've done and put that into C++. So borrow checking feature, which is in development, will enable ref and ref mute keywords. Those are both types, like new kinds of borrow reference types, and borrow expressions. The compiler checks the invariants. It allows multiple refs, multiple immutable refs to an object, or one mutable reference to an object. Same as Rust. It also does a lifetime analysis of the borrows so that the value you borrowed from cannot expire before any of its borrows do. And there's also there's a need to lower this to a mid-level IR and then do this control flow analysis to make sure that the borrows don't outlive their objects. There's a need for new plumbing. How do you do borrows of things that are on the heap? So the heap is not on the stack. It's hard to, like, you don't know when the object on the heap was created. Well, then there's dynamic checking. There's like the ref cell and the cell, and there's the reference counted types in Rust. And these are, I'm not sure if they're Rust library or Rust core exactly, but we have to have a full solution to allow a seamless handoff from static borrow checking to dynamic borrow checking and back again. And I think this is something sensible. You know, Strustrup asked for something sensible. I think modeling a feature based on a popular language that's had success convincing people about memory safety is a good thing to do. And as far as putting this into C++, like I'm not the kind of person who tries to shame people into programming the way I program. Like I'm not really sold on code smells or anything like that. You can do whatever you want. I only have like really one guiding light, which is separation of concerns. I talk about that all the time. I think it's important to separate borrow checking and other memory safety features from all the other features. So I'm trying to add this without thinking about lexing, parsing, overloading, pattern matching, interface generics. Those are all irrelevant. The Val programming language project, it came out strong with this idea that mutable value semantics, which is maybe an arguably simpler way to achieve memory safety without borrow checking. It's an alternate form of lifetime management. They said this is the way to do it, and so that's good. And to deploy mutable value semantics in a language, we're going to create an entirely new language from scratch. But the value of that is in the mutable value semantics. The value is not in how you implement generics or how you implement pattern matching. So I think we get a lot more research bang for our buck if we can take C++ as a core language and then specifically innovate on the feature we're worried about and not take on all this responsibility of creating a new language, which is what the Carbon experiment and the Val experiment do. They say they're experiments, but they're not isolating any single phenomenon. They're trying to innovate on everything, and I think that is a hard way to do research. Parameter directives, this is a Herb Sutter talk from a few years ago, and it always comes up. It's kind of, it's a seductive idea that you can annotate parameters with keywords like in, out, move, and forward, and that will tell you what they should do. And that's shows intent. It's better than references because it shows intent. I tried implementing this several times, and I couldn't do it. I couldn't close the loop. I can't figure out the semantics for these parameter directives. So I thought, oops. Uh-oh, did my clumsy finger. Here we go. I couldn't figure out how to implement parameter directives. So I said, well, be creative, flip it around. So what if we had argument directives? What if we put pretty much the same directives right on the argument as opposed to the parameter? These are explicit. So on line 7, I'm copying an object. On line 10, I'm moving it. Line 13, I'm doing a relocate. It's implicit there. On 16, I'm doing a borrow. On 19, I'm doing a mutable borrow. You can see the definitions on 1, 2, and 3. Now, this happens to be exactly like the Rust object model, right? You can move things by value, which is a relocation, or you can move them or you can borrow from them. The borrows are checked, and passing things by pointers or legacy L value and R value references remain unchecked. I think this, for me, this is the future of C++ object model. I think it has a lot of advantages over the L value and the R value references that Herb, I think he's accurate in his diagnosis. He says those are confusing, and they are confusing. But I think marking up parameters, for me, has been unproductive. It's not borne fruit. But I think going down this argument directive way is going to be really great because everything's explicit. We know the cost of a copy. We know where the expensive operations are because we can read them. We know that moving an object will steal its resources. So later on, if we use it, it's been stripped of its resources. Line 13, that's a relocate. We can't use object later than that. And the bars are explicit. So I think modern software design is about making things more explicit rather than less. All right, so we're reaching the end here. I think there's been a lot of discussion about decades of technical debt. I think that versioning is a framework that earns C++ decades of life. I'm just discovering the potential of C++ tool chains. There's no knowing where development will take us. We have to create to learn. And so this is like a idiosyncratic thing. So I've decided to give a book recommendation at the end of all my talks now. I've done it once already. I read a lot of novels, like 30 novels a year, and it's been good for my productivity. If I was asked how to be more creative, I would say, read literature, read a diversity of it, talk about it. You're exposed to multiple registers of language and modes of communication and points of view, and that makes it easier to surrender your own perspective. And that creates a mental agility, which makes it possible to find the unseen phenomena or unseen connection between phenomena. And I mean, that's just saying I like reading books, and I think it's helped me in this pursuit even. So my book recommendation is Shirley Jackson's We Have Always Lived in the Castle. She's a really fascinating writer. She died at 48, but she wrote 200 short stories and 6 novels in that brief life. And she's really our preeminent 20th century horror writer. And she reads a lot differently from someone like Poe. So it's kind of the Gothic setup, but not just pits and pendulums and immurements in wine cellars. So she wrote in 1948 The Lottery. This is online in the New Yorker magazine website. It was published in the New Yorker in 1948. It created a moral panic, and people wrote her death threats. They said she was like the devil, and I think that changed and she was really young at that point. It changed the trajectory of her life, and she became, at least in the popular imagination, kind of a recluse. And that makes it easier to identify with other recluses in her books. The Lottery is about a lottery, and then everyone goes to the town hall and they draw a paper, and then there's something very grisly at the end, which you don't realize. But this is the foundation for all this young adult Hunger Games stuff. It kind of came from this very clever little short story. She's famous for The Haunting of Hill House, and We Have Always Lived in the Castle, which I'm recommending. There's a recent biopic with Elizabeth Moss, who played her, and I think when Elizabeth Moss plays you in your biopic, you know you've made it. So I would suggest this novel. It's about the bond of sisterhood and about alienation and how we build fortifications. They fortify their house to prevent them from the townspeople who hate them, but we have always lived in the castle. You learn kind of that their psychological defense is a form of castle as well. So don't go in cold, don't spoil it for yourself. So that's all I got. No questions, go make language evolution. Go. All right.
Is this working? Yes, cool. All right, 2 mics it is.
So spelling it feature on no implicit conversions just feels a little off to me. It seems like implicit conversions should be a feature that's on by default because it's part of what C++ is today. And then if you want to turn it off, you do feature off.
Thank you for your input.
Really, really cool project. Really impressive. I mean, I'm personally, I'm a professional language opiner, but not for C++, but for JavaScript. I'm on the JavaScript standards committee. Anyway, we've been using Babel, a JavaScript to JavaScript compiler for experimenting with new features for almost a decade now, and it's been really important. I mean, maybe played a similar role to what this should hopefully play in C++ in the future. So I'm very happy to see that you're working on this. I do like standards, but I don't want to like debate that. Anyway, I wanted to ask you, how do you plan on maintaining this project going forward in terms of, I mean, I really like your program of which language features you're adding right now, but do you plan to open it up to other contributors, adding more features? And if so, like, how would you decide because for every matrix of different features, there's all these possible interactions. Babel ended up it was initially kind of a free-for-all with different ideas. And then it ended up being kind of aligned with what was being discussed in the standards committee, just to not be too crazy. But of course, that has these costs that you explained really well. So just curious what your thoughts are.
Yeah, that's good feedback. I wasn't aware about the JavaScript angle, but I know that there's precedence in some degree for this for Rust with additions. And Python has futures, which is a way to kind of change the language based on naming which features you want to activate. And then Haskell has like more than 100 features you can enable. They've really gone crazy with it. And I think as far as, you ask really a governance question, like how do we know what to put into it? How do we get, I think part of this is about like which vendors want to go in. So if Circle is the only compiler that wants to do this, then it's just like the dictator of me. I'm the one. But if like Clang or I don't know, if it's hard to imagine like other vendors saying, yeah, we want to do this thing. Because right now it's like they don't want to do even like ISO work really that hard. So I don't know. The answer is I don't really know about.
I guess I was asking, how do you want to do this going forward? Like what do you see as like the next things?
Right. So ideally, this would be funded by companies like institutional users, ones that employ a lot of people, and they would contribute financially and with human resources for maybe a foundation to keep full-time compiler engineers, and they have like voting rights. If they fund 20% of the organization, they'll get essentially 20% of the time, and they say, these are the things that our language opiners are interested in. Can you build this for me? We're going to help spec it out for you, and it gets put in that way. And that's clearly easier if there's only one vendor. But even if there are multiple vendors doing this feature thing, once you get it into one implementation, it's pretty easy to specify these things, and hopefully would go. I just want to shake up the landscape right now, which is antagonistic to creative process. So I'm sorry, I don't have anything specific right now for you.
I don't know. That all sounds really great. Keep it up.
Thank you.
On a similar note, if other compiler vendors, if the standard committee do start getting involved in features, it seems to me that there's kind of a new namespace problem with people having to compete over feature names. I don't know, I guess that's something to think about. Like how would, do you need like stood features and, compiler specific features?
I think that would be a great problem to have. If there are so many people doing compiler development where we need deconfliction to prevent them from all like using different identifiers, if we need like an FAA that controls like air traffic of features, that would mean like this thing has gone gangbusters. But right now, like I'm the only one who's using this or developing it. I mean, in the far term, we would have to figure out a protocol, but that's a long time, and that does presuppose like success as far as embracing this kind of path to upgrades. So
Yeah.
So how do you handle features kind of spilling out of the feature on or off? For example, I assume you'd want to be able to use namespaces, use interfaces that you define outside of the feature on interface.
You can't use the feature on interface activates 4 keywords.
Right.
So you can still use interfaces, but you can't use the interface keyword, et cetera. The point of the feature is to prevent conflict with existing code. You have to think about it from a compiler standpoint. there's a AST and there's a type system, and those do not get conflicted. So there's an interface entity, there's an interface template entity, there's a DINE type entity. Putting those into the compiler doesn't create any kind of compatibility problems. Exposing them through a syntax does create compatibility problems. So the feature just tries to gate how these things are exposed from the translation of tokens into AST or the type system.
So another example that might be a little bit more interesting. Let's just say I turn off the feature for integer promotions, define a template, and then I expand the template somewhere else.
Right. Templates are easy to think about because the masks from the beginning are defined for each token. So whoever defines that template body, it's the template that sets its features, not whoever instantiates it. Because you're right, like, so if you have file A and that feature ADL is on in file A, and it defines a template function, and file B doesn't have feature ADL, and it calls it instantiates that template. That template's instantiated with the features that were active when it was defined. There is some conflict though. For instance, the forward parameter. So you can have a redeclaration with or without the forward keyword, and they're like the forward keyword will change the type. So if you use like a legacy forwarding parameter versus the new forwarding parameter, those are different types. So overload resolution will like say, oh, well, you're doing two slightly different things here. The type system can have disambiguating features in it disambiguating qualities to prevent features from clashing. But I think understandably, there's a little bit of hesitancy with people thinking like, well, there's got to be a lot of like corner cases. But I think the burden would be on that person to come up with a corner case, really, because I can't like prove negatives. There are some corner cases with the way type traits are defined inside headers. So a type trait is defined in a header that's ISO standard, right? And then if you use the type trait, you say, well, like, is there a valid promotion here? Well, like, it'll actually instantiate the type trait in the header, so it's a different feature space. There are some little caveats there, but this is, I think, really resolvable.
Okay, so I have two questions. The first one, I think maybe you just answered, but the ability to turn features on and off within on specific lines of a file.
Don't do that. That's for illustration. So if you're a curious programmer, you're going to probe at the compiler. Like for there, it's really easy to do one thing, set a feature, and do another thing. But from actual use, right? Have a project.fts file or something like that. Have a single file for your project, unless your project is enormous, and then you may have multiple ones. And just list your edition there. So for most people, this would be like edition 2025 or whenever they migrate to this, plus whatever ones that their project leads set. So you have a text file, normal text file, you list the features you want in it, and then you pound feature include that file at the top, and now that whole file has those features on it. The doing it on an individual line is really just for illustration to kind of help people understand the mechanism. Because I think it's important to have, I don't want to seal it up because I think it's important that curious people should be able to probe at the compiler and understand what it's doing, because that's how I've learned like how C++ works and how other languages work. So I want to allow you that opportunity, but again, that's not great practice probably. Yes, there was active disagreement. The direction group called me out by name like 2 months ago in a mailing where they said like circle is a variant and it's a dialect and it's not C++. And like, yeah, I want to create essentially dialects, but they all are mutually compatible, right? There's a single type system, there's a single AST, but from the user perspective, there's different flavors for the language. I think that's great. I think that's freedom. I think that's John Locke liberalism. But the direction group, they're ISO-brained. Features they like are necessary. Features other people like, the language is already too complex. There is active disagreement. But I don't know, maybe these things are changing. Like Bjarne has what is it called? Profiles or flavors or what is it? there's a profiles mailing. It came out like a week ago, and it doesn't indicate what a profile is. It doesn't name any profiles, it doesn't show any in use, but it sounds like a feature. So maybe there is a way, a path forward. I don't know. Maybe mine can be changed. I don't know. But again, I haven't really been proselytizing this very long. I only came out publicly with this like 5 weeks ago. So this is like kind of fresh stuff. Still hold it in front of your face.
Yeah, I think I can speak now. First thing, congratulations, really nice framework, I can say, or compiler. I have a question. Do you have any tests in the combination of Cycle and using NVIDIA CUDA? Because CUDA usually, I see like other different programming languages completed. Do you test the combination of CUDA code and Cycle code?
I love CUDA. I was at NVIDIA Research in the early CUDA days, when it was the wild west of CUDA, and I did much CUDA, and I haven't really, I have like a long CUDA page on this from, I don't know, 2 years ago, and there's like a lot you can do. So I have if target that was brought into the NVIDIA compiler. It's like a really cool CUDA compiler. I actually have an example of using the standard library, like standard library calls that I downloaded like some open source newlib or some like real embedded libc, and I compiled it for CUDA. So you can use like libc stuff on the device. I don't know if I have virtual tables. I think I have RTTI. I just have a lot of features. Yeah, I want this to target CUDA, absolutely, because I would say that high performance computing has had a transformation in the last 5 years, and ChatGPT and all these like annoying computer generated pictures of presidents looking like with ponytail. I don't know. Like there's so much content out there, and it's all driven by massively parallel hardware, and that's all programmed in C++. So if you can make those GPU programmers' lives better, then that helps produce more of this very interesting content we're seeing. So yeah, I'm all with CUDA, and I have a lot. You can check my website. There's some kind of out-of-date links, but there's a lot there. It's like there's a lot of ideas there.
We might have a second. No, we don't have a second mic.
It's okay. So this is just a question out of curiosity. Just out of curiosity, like, so what is the effort for adding these features? Like, is compiler engineering like harder than coding in C++ with like the existing features, or is it different? I mean, I know it's a very subjective question, like it depends on the years of experience and the feature you're adding and all that, but if you have to start, like suppose I like a feature in Python or something else and I want to add it to C++.
So the question is 2 parts. If I really can summarize it. Number 1, is compiler coding harder than other coding? And number 2 is adding a feature hard? And I think adding a feature, unless it's like interfaces, is easy. A lot of these were really easy. Some of the features might take me like less than an hour. You go in, you like reserve some new keywords, and then it does one simple thing, and that's beautiful. The compiler programming is harder than normal programming because you have to know the C++ language. And if you're like a language opiner, you think you know it, but when you write compilers, then you really have to learn it. And that's really hard. So like I've seen things you people wouldn't believe as far as code. And I always, it's like, what perverse mind came up with a lot of this stuff? I mean, the template stuff. That's why it's hard, because you are facing the nastiest things imagined by C++ people who are not the most like balanced minds on the planet. So I don't think compiler programming is intrinsically that difficult, but C++ compiler programming is very hard because you have to support users who are like way outside like normal thought. So just figuring out what they do is really hard, and then like figuring out the semantics, because the language has so much leniency and there's so many non-standard extensions. That's very difficult. So I think like if you want to do core feature development, you have to buckle up because that's a wild ride, yeah.
One more or call it there? All right. Last one.
Oh, I hope it's a good one. So one person in 6 months was able to create 30 features, right? I'm curious if you've put any thought into like over time, features are going to escalate and grow exponentially as more people get involved with this. Do you see a problem of like essentially so many dialects of C++ that look so different from each other? We no longer have like this one language that when a person switches jobs, they bring that background knowledge with them.
All right, this is another very good question because it supposes that all of this is wildly successful and that everyone has adopted it, and all of a sudden there are thousands of C++ front-end engineers. So that, like, you're assuming that these ideas are so potent that there's been a sea change in this industry. Like, I'm happy with that, no matter, even if it leads us to a Tower of Babel situation, like that will straighten itself out. There used to be a whole bunch of vendors. They've kind of standardized, even in stuff that's outside the ISO standard, like the Itanium ABI now dictates for every platform except for Windows, like how binaries can talk to one another. Is there some committee? Is there like a central foundation that says, okay, like this is an addition critical feature that we want to ship? Do all C++ compilers ship some like predetermined set of features? Are there mandatory features? I don't know. But I think there has to be a lot of successes between here and that being a problem. I think there's a similar question earlier on about this, like, what about all the dialects? What about, oh, that's right, what if we have features that are like, there's two interface features and they're like subtly different, right? And that is a problem, but again, it presupposes that like this has now supplanted ISO C++, and this is the way systems level programming is done. So I think I'll like tackle that problem when we get to it, but that would be a great problem to have. Just there's too much enthusiasm. That'd be great.
All right, I think we're going to call it there. Thanks everyone so much for coming out tonight. I had a great time. Hope you did too. Thanks, Sean. This was awesome. And we're going to be having another event, I think April 6th, I'm hearing, back over at Adobe. And Brett Brown is going to be talking about something that's definitely not tooling. No, it's tooling. Thank you. These go in here, I think.
I don't know why the mic died.
Don't worry about it, man. It was fun. Hey, thanks so much, dude. This was awesome.
Look at this. Look at this.
I know. I have no idea. Yeah, a couple of us are going to go to the bar if you're interested.
I think
Just being around for me, but yeah, next time. All right, thanks, dude.
yeah, no worries.
A couple of us are going to go to the bar.